Okay, today we start a new unit. Chapter 5 is all about probability. It's all around us. You're going to see some examples right away. There's some examples of probability and how often it's used in any subjects, okay, in everyday life. All right, so here's our learning targets for 5.1. We'll get through all 4 of these today. It's a pretty quick and easy section. 5.2, 5.3, we're going to have to kind of slow down when probability gets a little more difficult, okay? So we're going to work on assigning probabilities to events and how to do that and the range of values. Talk about the law of large numbers and how it relates to relative frequencies. Some real basic rules of probability to get things going. And then the relationship between stats and probability, okay? So what I want you to do first is get to page 194. I want you to read some of these intro examples that they're going to bring back up later, and then go ahead and fill in the definitions for probability and probability assignments. All right, so go ahead and take 3 or 4 minutes to pause and do that now. All right, so as you can see, the range of values, it's always going to fall between 0 and 1 because probabilities naturally start out as a proportion, as you're going to see. And once we divide that proportion, we get numbers that fall in this range. Okay, so if it's 1, it's going to be, if it's certain to occur, if it's 1, okay, and 0 is the other end of this range where it's certain to not occur, almost impossible. Okay. Okay, and this is how we read this P parentheses A. What does that mean? It means probability of event A. And a lot of times we'll have context for that. What is event A? A lot of times we throw it right in there, like probability of drawing a face card out of a deck of cards. We'll put drawing a face card. Okay. All right, so let's go ahead and move on to the next page. Okay, so when we get these probability assignments, sometimes we'll create it off intuition, all right, based on our observations. What are we noticing is happening? Okay, so that's what they mean by intuition, based on your experience, then create a probability off that. Maybe you actually have data. If you have actual data, I flip a coin 10 times, and I'm recording the probability of getting heads. Well, maybe it happens 6 out of 10 times. So that would be why they're calling it relative frequency, right? From last chapter, we had relative frequencies that were turned into decimals, like this. So there's a basic example. Like I said, flip a coin, record it. Now you can base probability on past results. All right, and then you can also create probability assignments based on what you expect to happen. They also call this theoretical probability. If I flip a coin, what is the equally likely outcome to happen, right? It should be 1/2. All right, so this is what's expected, and then this is based on what happened after you did it, okay? All right, so let's go ahead and take a look at example 1 on page 194 through 195, expressing probability results before we give this a try. Okay, so pause to read that, and then we'll talk about the blue box together. Okay, so the idea of this example was to go through and find out whether it's intuition-based, relative frequency, or what I like to call theoretical probability. And they also say equally likely outcomes, whichever. Okay, so this one, the answer was intuition. Based on their observations, that's what they're predicting. That's their prediction, okay? Next one is kind of like that flipping coin example I gave you. If you're going to guess on something that has a true false or something like that, it's based on just the theoretical probability, what we'd expect to happen if we did it in the long run, okay? And then the last one was based on results, based on data, relative frequency, okay? All right, now when we express these probabilities, there's a lot of different ways we could do this. If it's going to be in fraction form, typically we reduce it if it seems reasonable to do that. We can also report it in decimal form. We can take decimals, change them to percents, which a lot of times us humans like percents. It makes sense to us. And also you can keep it as an unreduced fraction. Okay. All right, so let's go ahead and try guided exercise 1. All right, you pause, you try it, and then we'll go over the feedback together. Okay. Let's do that in your notes. Okay, here's your feedback on this. This was based on what happened. We take the results, divide it by the total, okay, and we get relative frequency. This is how we always set up probability of the event, right? We put the total number of outcomes on the bottom, and then the number of outcomes favorable to the event that's the topic. So in this case, wear glasses or contacts, 375. Okay, so that's an unreduced fraction. Punch it in to get a decimal. Maybe some of you put 75%. That's okay too. Okay, so this is based on relative frequency. B, this is the theoretical probability. What would we expect? There's 4 members in the committee, and 1 will be drawn. Okay, so everybody has an equal chance of occurring, so that's why it's called equally likely outcomes or theoretical probability. Okay, probability of it being George or just any of the individuals. Okay, so probability to film a whale is approximately 0.95. So you want to choose something close to 1. They didn't really give the amount, but almost certain means it should be getting close to 1, right? They didn't say certain, it said almost. So maybe you chose 0.99, maybe you chose 0.98. That's why I put this squiggly line somewhere close to 1, okay? And that's based off intuition. Okay, that brings us to law of large numbers. I talked about this a little bit already. It's all about long-run probability. Here's just a basic graph of flipping a coin. They're tracking the proportion of heads. So for a small sample, the first one was a heads, then it was a tails, so 50%. Then it was back to heads, so 2 out of 3. So for the short run, it's kind of volatile, right? It's up and down. Of course, we're not always going to be 50%. It's going to be around 50%. But in the long run, as the samples get larger and larger, this one is 500 tosses. What do you expect? Well, eventually it's going to approach its theoretical probability, but not in the short run, only in the long run. So that's the idea of law of large numbers. Okay, so the relative frequency, 0.5 in that case, will get closer and closer to the true or actual theoretical probability value. Okay. Businesses and models and casinos, create their business models on just that. What do they expect in the long run? In the long run, you guys don't win. We don't win. They do. That's why they're in business. Okay, they count on that. Okay, let's go ahead and find these definitions in your reading now, and then we'll continue. So pause and read and fill it in. Okay, so simple event. Let me just use a deck of cards to explain this. Is one particular outcome, like probability of drawing a 5 out of a deck of cards. Well, there's 4 5s in a deck of cards, so that one particular outcome would be 4 of those out of 52. The sample space goes in the denominator. That's the set of all simple events. So my possibilities are all the 4s, all the 5s, all the 6s, all the, everything. Okay, so that's what we put on the bottom. Okay. Event can sometimes be a collection of one or more outcomes too, like drawing a face card. That's jacks, kings, queens, So whatever they define it, just figure it out. All right, so let's look at example 2, using a sample space. Go ahead and read that to yourself, and then I'll help you fill it in. All right, so you just kind of use this as a grid format. They kind of filled this in for you, but mother has, if you get from your mother the B and from the father the B, then you have blue, meaning you'll have blue eyes for that one. Okay, but the other outcomes, you get L and B and L. This one was missing. I think the LL, I guess they're all filled in, weren't they? But this is the sample space. Okay. All right, so what's the probability that they'll have brown eyes or blue eyes? Well, probability of blue eyes is equal to this event right here, 1 out of 4. Probability of brown eyes would occur for these 3 scenarios from what they described. Okay? All right, the next example is something for you to try, similar to this. So pause and give it a try. Sorry, I had that backwards. The blue eyes is here, these lowercase l's. So that's the 1 out of 4. It still didn't change the probability. And then these are the brown eye scenarios. Okay, here's your feedback. Here's the 2 outcomes that were not listed. This doesn't have all false, and this doesn't have 2 false, then a true. Okay, so those are the 8 total outcomes for our sample space. All right, so what's the probability that all 3 items will be false? That only happened once. So 1 out of the total outcomes. 1/8. Okay. What's the probability that exactly 2 items will be true? Go through the sample space and figure it out. It doesn't have to be the first 2 or the last 2, exactly 2. So we've got this one here, this one here, this one here. So that's 3 out of the 8s. Okay, this is something that we need to know too. The sum of the probabilities of all these simple events always equal 1. It happened right here, right? 1/8, 1/8. If I add 1/8 up 8 times, I get 8 out of 8. Adds up to 1. Here's another example in terms of decimal form. If you think your probability is 0.65 that you win a tennis match, well, the probability that you lose then is 0.35, right? These should add up to 100% if we convert them to percents. Here's how they usually denote this. The complement is what the phrase they use for is the technical term for this concept. Complement of an event, A. A does not occur. It's A with a little C up in the corner, okay? Meaning complement of A. All right, so let's go ahead and wrap things up with just that concept. Pretty easy. Read through it and try example 3, and we'll be done for today. Okay, so a couple different ways we could use that property. Remember, 65% chance of winning plus 35% of not winning equals 1. Okay, but if we know 1, we just take it away from 1 to figure out the other. So the probability of not winning is equal to 1 minus 0.65. Okay. All right, so we could actually write this in words too, like they did in the book. Probability that they will not get the flu, or you can actually define the event like this, like I did. I want to try this. Let's just call A the event getting the flu. Okay, so the probability of not getting the flu was 1 minus 0.45. 0.55. Okay, there's a little more, some more concepts in 5.1, but for the most part, this is going to cover what we need to know from 5.1. So that'll be it.